Hello everybody, welcome to this very important class of organic chemistry. If you are a student of organic chemistry, then you must have heard the term SN1, SN2 and so on. So many reaction mechanisms are there. Reaction mechanisms means the way by which a reaction proceeds. We shall discuss particularly in this class one type of this reaction and which is SN1. Okay, now what does SN1 mean? Now before going to that, first of all we shall consider two examples of substitution reactions. Let us write down the reactions first. Let us consider this reaction CH3. Now if we consider these two reactions, then one interesting point is noticed. What is the interesting point? That is, if we consider this reaction, then in this case the rate of the reaction, that is how fast or how slow the reaction proceeds, depends on two factors. One is concentration of this, another is concentration of this. This is the substrate and this is the reagent. So in this, rate of the reaction depends on this and this. That is, here if we consider this, then rate of the reaction equal to some constant into concentration of this, that is CH3Br into concentration of NaOH. That is, if we change the concentration of this one, the reaction will change also. If we increase this, the rate will increase. If we decrease this, rate will decrease. Similar thing will happen for this one also. From this it is very clear that if we increase this one, rate will increase, that is the reaction will become faster. If we lower this one, then the reaction will be slower in nature. But one interesting point is observed in this case, that is, in this case if we observe the reaction rate here, then the rate will be related only on the concentration of this, that is, it will be dependent only on the concentration of this thing, not on this. Okay, so reaction is directly proportional to this, reaction rate rather directly proportional to this. So if we change the concentration of this one, the reaction rate will accordingly change and it will remain indifferent on the concentration of this one. So the big question arises, why? What is the reason behind this? Now in order to explain these things, we must know how the reaction proceeds, that is, what is the mechanism or what are the mechanism behind all these reactions. If we consider the mechanism, then only we shall be able to explain this phenomenon. Okay, so in this class we shall discuss what is the reason behind this to be dependent on this only, not on this. And to explain this, we have to consider how the reaction proceeds. So we are not discussing here this one in details. We shall go through this and we shall see how the reaction proceeds. Now let us consider the reactions again. CH3Br. This was the substrate. Look, in this one interesting point is there. If you consider this carbon atom, this is 3° carbon atom, and since it is 3° carbon atom, it readily forms one cation, and cation may be formed if this bromine along with its own electron and this electron of carbon leaves the system. Okay, that is, if it departs from here, then what will remain in the original substance, and this will be the remaining part. This will be positive and bromine will come as Br minus. Look, this is one carbocation which is 3 degree in nature, or it is termed tertiary also. So tertiary carbocation, this is very stable. Since this 3 degree carbocation is very stable, so in this reaction very often this will readily form this one first. And look, in this process there is no role of sodium hydroxide which is already present in the reaction medium. So this reaction takes place in the first step, and this is the major step. This is called rate determining step for the reaction, and eventually this is the slowest step, and this is the slower rather compared to the next step. Now look, in this one carbocation is formed, and if this carbocation is then allowed to react with OH minus, readily it will form the corresponding product, and which will be this. So from here we are getting this one. This step was the major one, slower one. This step will control the rate of the reaction, where only this substance has some role, and so this reaction as a whole is a reaction where only the substrate contributes. Look, another thing, this is altogether a substitution reaction where Br is replaced by OH. Since one group is substituted by another group, this is called substitution reaction. This is a substitution reaction since one group is substituted by other. And in this, which one is helping in the substitution? Look, this is coming from NaOH, and in this OH minus, since it is negative in nature, so this is called nucleophile. Nucleophile means any nucleus loving ion or group. This one being negative, so it will prefer nucleus. We know that in nucleus positive charge is there. So since nucleus is positive in nature, so this will love nucleus type of substance where positive charge is there. Okay, so it is called nucleus loving, or in one word, nucleophile. So this substitution reaction is taking place by one nucleophile. So this substitution is called nucleophilic also. So the term will come here, nucleophile, and due to the presence of nucleophile, the reaction caused by the nucleophile is called nucleophilic. So the reaction is now nucleophilic substitution, and already we have discussed, since this is the major step, main step, where only this substance or one molecule here is participating, one molecule is contributing towards the speed of the reaction. So this is unimolecular also. So all combining these and these, the reaction is termed as substitution nucleophilic unimolecular. So in this way the term SN1 comes. Now we shall discuss another very important point associated with this, and the point is the role of solvent which is used in this type of reactions. Now to explain the role of solvent, up to this is sufficient. Now we know that in the first step of SN1 reaction, one carbocation is generated. Now if we use one solvent which stabilizes this one, then the solvent will help the reaction, in other words. And if we use one solvent which will have no effect on this, which will not contribute anything towards the stability of this, then this type of solvents will have no effect, will be not applicable, will not be suitable for this type of reactions. Now the question arises, what type of solvents will be helping the stability of this thing? Now let us consider one thing. If we take water molecule, now water is ionized partially in this way, that is charge separation will be there, and this type of solvents which, if allowed sufficient or proper condition, may form proton. So this type of substances are called protic substances, protic solvents, and initially it was polar in nature, so this is altogether called polar protic solvent. Similar thing will be observed in case of ethyl alcohol, in case of methyl alcohol also. So all these are polar protic solvents. Now if we consider these polar protic solvents, what will happen is that here two substances are there, so water will stabilizes this one in this way. This is partially positive, this is negative, so one kind of attractive force will be generated here, so they will remain associated to each other. And here also, if water molecule is there, then with this positive charge, the OH negative, that is this portion, will stabilizes this one. So in this way, one part of the solvent stabilizes this one, another part of the solvent stabilizes this one. Rather, this one will stabilize the cation, H part will stabilizes the bromide ion. So in this way, the solvent will stabilizes both of the substances obtained by the dissociation of this bond. So polar protic solvent will help the reaction to proceed. And if we take any other solvent like acetone, CH3CO CH3, this is not a polar substance, this is not a polar protic substance. So what this is, one kind of substance which is not polar at all, which will not stabilize this one or this one, so they will have lesser effect on this reaction, rather they will not help the reaction at all. Now in these reactions, another very important point is to be considered, and the point is, if we take in place of bromide any, rather bromine, any other substance like iodine, like chlorine and so on. Now what will happen in these cases? Now look, the major step, the main step for this reaction is the cleavage of this bond. If we take iodine in place of bromine, then this bond, that is carbon iodine bond, will be cleaved more easily, because this has strong leaving group aptitude. This can leave the system more easily. So this reaction then will be even at faster rate. And if we take carbon, rather chlorine in place of this one, then this bond is strongest among these three, so this bond will be least effectively cleaved. This will be reluctant to be cleaved. So this substance, that is in this, if we take chlorine, this will show minimum reactivity, rate of the reaction will be minimum compared to this one and this one. So altogether we may say that the rate of the reaction will be maximum here, then it will be for this, then it will be for this. So in this way greater the bond strength, lower will be the rate of the reaction for SN1 reaction, that is the reaction where substitution, nucleophilic and unimolecular type of mechanism takes place. Now the last and very important topic for this reaction is geometry of the product obtained. Now what will happen if we take in this and this different type of substances, different type of groups. Now let me show this with examples. Let us consider one substance where all CH3 group is there already, which we have discussed, then no difficulty will be there, this will be formed and then ultimately it will form the simplest substance OH. No difficulty is there, but some complication will arise, some difficulty will arise if we take this one here, another group here, another group, and in general we may write down them in this way, R dash. So if this be the case, then what will be the nature of the product? Now similar thing will happen in the reaction mechanism part. Initially this will form carbon and 3 R groups in this way and it will be positive. Look, in this is this bond, this is this one and this is third one. Now if we write down the 3D structure of this molecule, then what will happen? Let us consider this one and this one, they are present on this plane, and this one is in the back side of this plane and this one is the closest bond which is above the plane. So if we represent this in this case also, then this will be like this, but one thing, since it is 3D structure, here one bond will be on the plane, one bond will be below the plane and some portion will be on the plane. But remember, this one is now sp2 hybridized. Since it is sp2 hybridized, so what will happen is that this will be planar in nature. So this all bonds will be present or may be present on the same plane. Now the complication will arise after that, that is if one OH minus is going to combine with this one, then two possibilities will be there. Look, I have already mentioned this is flat in nature. Now two things may happen. OH may approach to this carbon from this side or OH may approach from the back side. So in this, since these and these are different in nature, so two type of substances may be obtained. So if OH goes from this direction, then one type of product will be obtained. Let us consider this be the product. So it will be similar type of product to this one. Now if this one approaches from the back side, then this structure will be flipped. You may consider this one like an umbrella, and in this way the umbrella portion is there, this and this forming this type of structure. If OH approaches from this side, then it will be flipped. This will be flipped in this way, resulting the formation of one compound like this. So this product and this product, these two though are isomer to each other, are not exactly same. Their structures will be different. If you compare this one with this one, they will be actually the mirror image of each other and they will not be superimposable, and that is why these two substances which are not superimposable to each other, they are isomers and they are mirror images of each other, and if this be the case, they are called enantiomers. So this one and this one are enantiomers, and from here the possibility of formation of this product and possibility of formation of this product will be exactly same. So you will get a 50-50 mixture of these two, resulting a mixture of substance which is called racemic mixture, because this substance was optically active and this one is optically active, this is also optically active, but if this one rotates the plane of polarized light in clockwise direction, this will rotate the light anti-clockwise to the same extent. Mixture is called racemic mixture, and these two substances are called enantiomers. So this last portion, that is where the stereochemistry is different, the substance is different, the 3D type of substance is taken where each and every groups are different, is applicable for or required for higher competitive exams, but those who are approaching their board exams, maybe students of class 11, maybe students of class 12, or those who are not appearing for any type of competitive exams, they may ignore this part, but up to the solvent portion, each and every part is very important. So I hope you have now understood the basic things of SN1, that is substitution, nucleophilic and unimolecular 1. That's all for today. Bye bye.